All right, welcome back, everybody. ET 120, Engineering Problem Solving, Trigonometry, lecture number 2. And this lecture will not be on right triangles. We did right triangles. It'll be on non-right triangles. So non-right triangles obviously don't have a 90 degree in them. No 90 degree. So for non-rights, throw out the sign or the trig functions, sine, cosine, and tangent. Those do not apply to non-right triangles. Non-rights are either acute or obtuse. And you can think of obtuse as having a greater than 90 angle, such as this. So this is obtuse. Acute would mean that all of the angles of the triangle are less than 90. So just envision a triangle that looks like, that, where everything is less than 90, then you're an acute triangle. I don't really care that you know the terminology that well, but just an FYI. All right, so for non-rights, we still have the same equation for the interior angles. The sum of those interior angles is equal to 180 degrees. So summation of those interior angles is still 180. So if I know this is 10 and this is 110, now we're to 120, this has to be 60. Okay, so that's one of the first things I always look for is, hey, can I get all the interior angles? If I can, then I'm one step closer to solving this triangle. And now I need A and C. And since I can't use the trig functions, I have to have some other equations that I can use. One of them is called the sine law. So I'm going to write it A over the sine of A. Notice that I have lowercase on top and uppercase down below for the angle. This is angle, this is a distance. And then that equals B over the sine of B. And that equals C over the sine of C. Now, this can be written in any order and in any position. So I could write the sine of A on top and A down below. That would be fine too. I think this is the most common notation for it. And you don't use all 3 statements. You use 2 of the 3 statements and solve for it. Now, you've got to know 3 things of the 4. So if I'm using these 2 right here, I would need to know 3 things and then find the 4. So if I have C as a known right there, this is big C, and I don't know that, right? But then I have B as a known there, but I don't know B. Oh, I do know B, 30 miles. So if I did that, everything except for the C is solvable. So you look for the part of the equation that you can use and fill in 3 of the 4 things, so then you can solve for the 4th. So I know side B here. I know angle B here. I know angle C, but I don't know this side C, okay? So that'd be the one to work. If I tried to work with A, I don't know A, but I do know the 60. So there, and then I could do something like the B and the B, right? B and the B. So that would work too. So there's more than one way to go about this, obviously. The other equation, if this was to not work, like if you had a situation where you just couldn't get 3 of the 4, like maybe you know all 3 sides, but no angles, then you're stuck with this equation. So this does not work all the time. Sometimes you have to go to the cosine law. The cosine law is C squared equals A squared plus B squared minus 2AB cosine C. That's the cosine law. Now, if you've seen it before, then you're like, oh yeah, I remember that. If you've never seen it before, you're like, holy crap, that looks crazy. Yeah, it's a little crazy, maybe. But again, you have to know everything except for one thing. So I would have to know, to find C, I'd have to know A and B. Well, I don't know A. So this right away doesn't work. To find A, I'd have to know C, B, and big angle C. Well, I don't know C. I know big angle C, but not C. So in this case, this isn't going to work. So this most often works when you know all three sides and you want to find angle C. Okay. All right. So I'm not going to go too deep into this. I just want you to get the basics down, and we'll practice running this critter right here. Okay. So I said I could use these two or these two. Either one of those would probably work. So I'll just use the first two. And I don't know A, so I'm going to write A. Sine of A is 60. So there's that statement. And then I'm going to use this statement because I do know side B, 30 miles, and angle B, sine of 10. And those statements are equal to each other. That's how the equation sets up. So then you need your algebra to figure out the unknown. And you can only have one unknown. So if you set it up and you have more than one unknown, you're in trouble. It's not going to work. Okay. So I can solve for A by moving this over here. Sine 60 over 1. This is a multiply. And then I multiply sine 60 over 1, and those cross. So that's how the algebra works. What you do to one side, you have to do to the other. So if I multiply this side by sine 60 to get rid of this, then I have to multiply this side times sine 60. So A is going to be equal to, and this is just a number, and this is just a number. So let's see what we get. I have the 30. And then I'm going to need the 10 sine, and I'm going to need to divide that. So that's the 172. And now I need to multiply by sine 60. And it looks like it's 149, 6172. 149.6172 miles, because the miles stays there. It didn't get eliminated anyway. And it didn't get any unit multiplied to it because this is unitless and this is unitless. So 149.6172 miles. If I was going for a solution, I would round this to 6.2. But that's what A is right there. Okay. So you can keep using the sine law to get C. So I'm going to do that. So I'm actually going to run it with the original numbers and just use B over sine B and C over sine C. So there, if I have any error in this, it won't be introduced to this. And I'm expecting C to be longer than A, just based on this angle and this being 30 miles. This being 149 makes sense. Maybe my graphic is a little bit off, but it's definitely longer. All right. So let's check on C. I'm going to use B over the sine of B. So side B is 30 miles over the sine of 10 equals, and that's the B angle, so it goes there. And then C, which I don't know, over the sine of 110, 110 right here. Okay. All right. So let's run that. To get C, this comes across and becomes a multiplier. So C equals 30 divided by sine 10 and multiplied by the 110 sine. It's like 162.3442. 162.3442 miles. All right, so it is longer. This graphic may be, since this is 90 degrees and this is 110, 30 miles must be, down in here graphically. But these two work well with one shorter and one longer, and then 30 miles. So my graphic's okay. It's not perfect. It's proportional. It's confirming the numbers I'm getting. So, okay. I'm not going to run one of these, but Just know that that critter's there if the sine law doesn't work. All right. All right. Good luck with your non-right triangle lab. And I will check back with you on Friday when we will start our project. So I'll probably load that information tomorrow on Thursday. Those of you in GE 115 AutoCAD, we've had a number of events in that class. On Monday, the power was out, so I couldn't do much. And then Tuesday, the software expired for the college. So I'm definitely not the one that keeps track of that. It's it's the service desk, but they are working on it frantically. And I can show you that I am now installing the software on my PC, and I'll share it with you. It has stopped at 97%. So not just you all who have problems installing, but I haven't been able to get it installed. Supposedly it's still going incredibly slow. But as soon as it gets installed, then I will cover templates and put you on your new lab for this week in GE 115. I guess if it doesn't install, it could be tomorrow. Then you'll have probably through the weekend to do it. And then you will start your project. So both classes, ET 120 and GE 115, will have these projects started. You may use skills from each other's class. In other words, if you're in both classes and you know AutoCAD, you may use AutoCAD on your project. If you're just in ET 120 and you don't know AutoCAD, then you're going to have to do manual drawing for the project. Okay. All right. Best of luck. And I will keep you updated on my install and the project that's coming up. So great. Can't see my menu, sorry. Bye-bye.